Inductor and transformer. Inductor. Inductors are basically a coil of wire that may or may not trapped around a cord. Inductors have the ability to store energy in the form of a magnetic field. The measure of an inductor's ability to store energy for a given amount of current flow is called inductance. Inductance is symbolically denoted with a capital L and is measured in the unit of the Henry, abbreviated as H. An obsolete name for an inductor is choke, so called for its common usage to block, choke, high-frequency AC signals in radio circuits. Another name for an inductor, still used in modern times, is reactor, especially when used in large power applications. Both of these names will make more sense after you've studied alternating current, AC, circuit theory, and especially a principle known as inductive reactance. Inductors are also used in radios and other tuned circuits to form tank circuit. A tank circuit is basically a type of oscillator. Some inductors have a variable value. This is accomplished by using a screw to move the core in and out of the coil. These types of inductors are usually used in radios. Types of inductor. 1. An inductor designed for high power environment. It has ferrite core, which gives it a greater inductance ability, which makes it perfect for power supplies with a need for precise outputs. 2. An air core inductor, which offers little inductance in a circuit but does have a tick coil. This is a good example of something that you would find in a TV set or computer monitor. 3. A device with an inductance rating specified on its outer rings. Due to a thin coil and compact size, it is only suitable for such devices such as handheld radios and such devices with low power consumption. It looks like a resistor with usually green-coated body, but the color coding and reading of this is the same as resistor, but the unit is in microhenry, μH, or 10�6. Henry, for 4-band only. 4. A device that has a variable core for precision tuning for such devices as radio frequency discriminating. The coils are very thin few, which means that the situation in where this device can be in are very limited. Transformer. A transformer is a type of inductor made up of 2 or more coils, usually wound on some type of form. Transformer are electromagnetic devices used to increase or decrease AC voltages and currents in circuits. On August 29, 1831, Michael Faraday invented the induction ring. This was the first transformer. Although Faraday used it only to demonstrate the principle of electromagnetic induction and did not foresee the use to which it would eventually be put. Parts of transformer. 1. Primary winding. This refers to the input of the transformer where the main power source connected. A. Secondary winding. This is the output side of the transformer where the load is connected. B. Core. It is the metal or magnetic material placed inside the winding of the transformer to intensify the induction process of the transformer. C. Bobbin. This is usually made of plastic materials, used to support the primary and secondary windings. Types of transformers. 1. Auto transformer consists of a single continuous winding that is tapped to provide step-up or step-down function. In this type of transformer, the primary and secondary windings are connected. I step-up transformer is used if the output voltage of a transformer is greater than the input voltage. B step-down transformer is used if the output voltage of a transformer is less than the input voltage. 2. Isolation transformer is characterized when there are equal amounts of wire on each side of the transformer, it becomes isolation transformer. These isolate one section of a circuit from another, since there is no direct electrical connection. It is not directly connected to the main power source, thus reducing the chance of electric shock to the user. Another advantage of isolated secondary winding is that if any DC is present in the primary winding, it is automatically blocked at the form of winding. Types of step-down transformer. Step-down transformers are most commonly used in electronic circuits. It is classified into three categories based on tapping in secondary coil. They are 1. Single-phase step-down transformer, 2. Center-tapped step-down transformer, 3. Multi-tapped step-down transformer. 1. Single-phase step-down transformer. This is used to step down the current ratings and input voltage, and it gives low voltage and current output. Example. Output, 12 VAC. 2. Center-tapped step-down transformer. This type of step-down transformer is designed to provide two separate secondary voltages, VA and VB, with a common connection. The secondary voltages are the same and proportional to the supply voltage, VP, therefore power in each winding is the same. Example. Output, 12 volts, of, 12 V. 3. Multi-tapped step-down transformer. This type of step-down transformers have multiple tapping in secondary coil. Multiple tapping are used to get the desired varied output with secondary coils. Example. Output, 0 to 3 volts to 4.5 volts - 6 volts to 9 volts - 12 volts. Application of step-down transformer in electronic circuits. The various applications of step-down transformers includes 1. In main adapters and chargers for cell phones, stereos and CD players. 2. To step down the voltage level in transmission line. 3. In welding machines by reducing voltage and increasing current. 4. In televisions, voltage stabilizers, inverters, etc. Advantages of step-down transformer. The advantages of step-down transformers are as follows. 1. Useful in stepping down the voltage, thereby making transmission power easier and cheaper. 2. More than 99% efficiency. 3. Provides varied voltage requirements. 4. Low cost. 5. High reliability. 6. High durability. Disadvantages of step-down transformer. The disadvantages of step-down transformers are as follows. 1. Requires a lot of maintenance, failing which can damage the transformer. 2. Volatility and feedstock costs. 3. Fault rectification takes more time. Working principle of step-down transformer. Transformer works on the principle of Faraday's law of electromagnetic induction. Mutual induction between the windings is responsible for transmission action in a transformer. Faraday's law states that when the magnetic flux linking a circuit changes, an electromotive force is induced in the circuit proportional to the rate of change of the flux linkage. The EMF, electromotive force, induced between the two windings is determined by the number of turns in primary and secondary winding respectively. This ratio is called as turns ratio. The voltage reduction capability of step-down transformers depends on the turn ratio of the primary and secondary coil. As the number of windings in secondary coil is less as compared to the number of windings in primary coil, so the amount of flux linkage to the secondary coil of the transformer will also be less compared to the primary coil. Accordingly, the EMF induced will be less in the secondary coil. Due to this, the voltage reduces at the secondary winding compared to primary winding. Step-down transformer equation. The formula used to design a step-down transformer is where Ns equals number of turns in secondary, Np equals number of turns in primary, versus equals voltage in secondary, Vp equals voltage in primary. The number of turns in secondary winding should always be less than the number of turns in the primary winding of the transformer I.ENP ends to work transformer as a step-down transformer. As the number of turns will be less in secondary winding, so will be total induced EMF, and hence the output voltage in the secondary will also be less than the primary input voltage. Let's understand by considering the situation of step-down transformer in which the secondary turns, Ns, are 250, primary turns, Np, are 5000 and the input voltage, Vp, is 240. Then the voltage at the secondary, versus, can be calculated by using the formula. Inductor and transformer troubles. Inductor. Like other devices, inductors also run into various problems. The most common is that of an open winding. Acting as a power source, its characteristics are similar to a conductor. The inductor can be checked through continuity check using an ohm meter. Transformer. Another possible trouble is a short circuit across the primary and secondary windings. This occurs when excessive current flows in the primary winding, thus burning it out. Since both windings utilize the same bobbin, it is possible that the insulation coating for both windings will get burned out, thus causing a short circuit. Testing of transformer. A transformer is checked for continuity just like wire. Primary winding. 1. Set the ohm meter range in X 10 ohms. 2. Attach the test probes, any direction, to the terminal of the primary winding. The pointer should deflect. Secondary winding. 1. Set the ohm meter range in X 1 ohm. 2. Attach the test probes, any direction, to the terminal of the secondary winding. The pointer should deflect. Defective transformer. 1. Resistance of the primary or secondary winding is very low that the pointer almost stressed as 0 ohm, the transformer winding is shorted. 2. The resistance of the primary and secondary winding is very high that the pointer does not deflect at all, infinite resistance. The transformer winding is open. The end.